day, listeners. My name is Audrey Bolton. Welcome to our third educational program in a series of 5 produced especially for grade 10 mathematics learners. The main aim of these educational programs is to help you to understand the difficult content of this subject better. Today we'll continue with the natural numbers, but we're only going to talk about special types of natural numbers, namely square numbers and cube numbers. You'll hear various examples during the following conversation, so do have a pen, paper and a calculator ready to make notes and work out the examples on your own.
Wow, Susie, your aunt's amazing. You were right. She just has a way of explaining that makes everything make sense immediately.
Yes, I'm very fortunate to have such a wonderful aunt. Will you be joining us again today?
Of course. See you after school.
Good afternoon, girls. I see you back for more.
Yes, Aunt Mary, I told Susie this morning that when you explain these numbers to us, it makes so much more sense.
I'm glad I can help. Let's get started.
What are we doing today, Aunt Mary?
Today, we are going to talk about some of the special types of numbers, square numbers and cubic numbers.
Yeah, I always get confused between square numbers and cube numbers. How do we define them?
A square number is the result you get when you multiply the same number by itself. An example of a square number is 9. 9 is the result when you multiply 3 by 3.
But what about large numbers? How will I know whether the number is a square number or not? Isn't there another way to test it?
Yes, if you have a very large number and you want to know whether it's a square number, you find the square root of that number. If your answer is exact, meaning the answer has no decimals, then that number is a square number.
Could you give us an example of such a number, please?
Okay, take the number 225. You want to know whether it's a square number or not. Use your calculator to find the square root of 225. What do you get?
The square root of 225 is exactly 15, and there are no decimals.
Good. Which means that 225 is a square number. 15 multiplied by 15 is 225. But just like the multiplication tables, it would help you so much if you learn the square numbers off by heart. You should be able to say all the square numbers right up to 20 squared, which is 400.
Our teacher said the same thing, so I guess we had better do that. Hey, Susie?
Yes, you're right. What about cubic numbers?
Cubic numbers are the result of multiplying a number by itself 3 times. An example of a cubic number is 8. 8 is the result of 2 times 2 times 2.
So when you want to know whether the number is a cubic number, you find the cube root of that number.
Clever girl. When you have a larger number, for example 125, you can take the cube root of the number, and if the number is exact, that number is a cube number.
What if you don't have a calculator or you're not allowed to use one? How can you determine whether the number is a square or a cubic number?
Oh, of course there's a way. Let me show you. Write down the number 144 in your book. To the left of the number, draw a vertical line. We're going to divide this number by prime numbers, starting with the smallest prime number.
The smallest prime number is 2, so we have to divide 144 by 2.
Yes, 144 is an even number, so it is divisible by 2. What do you get?
144 divided by 2 is 72.
Correct. Write down the number 2 next to 144. But on the left side of the line, and write 72 below 144. Then, because it is also even, you divide 72 by 2. Write the next number below the other one. What is the answer?
The answer is 36. Do I write 36 below 72?
Yes, and 36 is also even. So write another 2 below the previous 2 and divide 36 by 2. Then write the answer below 36. What do you get?
I got 18. So I just go on like this.
Yes, what is 18 divided by 2?
It's 9. But 9 is an odd number and can't be divided by 2 without having a remainder. What do I do now?
Now, use the next prime number, which is 3, and continue from there. You keep on dividing until you get an answer of 1 in the right-hand column. Below the last 2, you continue with 3. So basically, you have 2 columns of numbers. The left column is the prime numbers, and those are the numbers we're going to work with. How many 2's do you have in the left column?
I've got 4 2's and I've got 2 3's.
What you've done is broken down the number 144 into the product of prime numbers. If you multiply those prime numbers with each other, you'll get 144. Try it and see.
2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is 48. And 48 times 3 is 144. Wow!
But we still don't know whether this number is a square number or not.
Yes, I know. To see whether it's a square number, use the product of prime numbers to make 2 identical groups.
You mean each group must have 2 2's and a 3?
Yes. Write down the following. Open bracket 2 times 2 times 3 close bracket times open bracket 2 times 2 times 3 close bracket. What's the result of each bracket?
12.
So the square root of 144 is 12. Or we can say 144 is the result of 12 times 12. You also have seen that if you write 2 and 3 with indices, the indices are even. It can be written as 2 to the power of 4 times 3 to the power of 2. 4 and 2 are even, which is why you could make 2 equal groups of factors.
Okay, that's not so difficult. And what a clever method. But I have some questions. The first number that we divided by was 2. But what if the number isn't divisible by 2? Which number do we use?
If the number isn't divisible by 2, you try 3. And if it isn't divisible by 3, you use 5. But it's very important that you only divide by prime numbers. Let's take an easy number. We know that 25 is a square number and that 25 is the result of 5 times 5. 25 isn't divisible by 2 or 3. Therefore, the first prime number that we can divide 25 by is 5.
Yes, that makes sense. My other question is, how do you know if we have a cube number? Do you make identical groups of 3?
Yes, you are totally correct. The method is exactly the same, but you make identical groups of 3. Let's take the number 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. So the result is 3 times 3 times 3. And there are your 3 groups. The cube root of 27 is 3. Well. I hope you could keep up with Aunt Mary's explanation and that you wrote everything down. Remember, you can't study maths if you don't practice a lot of examples. Let's go through the lesson again. First of all, square numbers and cubic numbers are special types of natural numbers. A square number is the result of multiplying a number by itself. And a cubic number is the result of multiplying a number by itself 3 times. Sometimes in the exam, you may be asked to express a number as the product of its prime numbers. Therefore, you have to know the method, regardless of whether or not you are allowed to use a calculator. You can also use this method to determine whether a number is a perfect square or cubic number. Let's go through the example Aunt Mary used. To know whether the number 144 is a square number, you start by dividing the number by the smallest prime number. In this case, we start dividing by 2. You make 2 columns. In the right-hand column, you write the answer after you've divided. And in the left-hand column, you write the prime numbers that you're dividing by. You can split the 2 columns using a vertical line. Once you reach a number that isn't divisible by 2, you use the next prime number, in this case 3. You keep on dividing until your answer in the right-hand column is 1. Then you write the number of prime numbers down as a product and divide them into 2 identical groups. For 144, you have open bracket 2 times 2 times 3 close bracket times open bracket 2 times 2 times 3 close bracket. If you have 2 identical brackets, then you know that number is a perfect square. You do exactly the same for the cubes, but there must be 3 equal groups of factors. Keep practicing and you will get it right. Listeners, that concludes our program for today. Thanks for joining us, and I hope you will tune in next time. From me, Audrey Bolton, goodbye.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.